And I'm going to record to the iPad. The other thing is, if once we get started, if you wouldn't mind, I would appreciate it if everyone would mute themselves. If not, when in the recording, when Tom will be speaking, and then somebody isn't muted and their dog barks, suddenly their face appears up on the screen. It's very disconcerting. If you have a question for Tom or for anyone else, you can use the chat function at the bottom, and you can either direct it just to Tom, or it might be better just to direct it to everybody so that everyone can see it, and Tom doesn't have to take a moment to look at the questions. And then at the end, Roy will probably be looking at those questions and choosing some of them to pass on to Tom. Okay, so that's it. If I see that you're not muted, then I will mute you. And if there's some of you I see that have your name is like iPhone, so often we'll recognize you, but sometimes we won't. So if you could make your name a little bit more obvious than just plain old iPhone, we'd appreciate that. So I'm going to pass it over now to Roy Luricky, co-president, to introduce Tom Bird.
Hi, it's a pleasure to welcome everybody to this Zoom session. This is the 7th session that we've done. The reception has been really excellent for the ones that we've done thus far. We've had Lou Eisenberg, Dave Shipler, Rand Beers, Dan Dimitrescu, Ed Williams, and Gib Myers already give talks over the past year. This has been very popular, and it's a great way to keep people engaged, as well as to see faces we haven't seen in a while.
We've had Bill Newcomb too, right? By the way,
and Bill Newcomb, right? Thank you.
Okay.
I'm going to turn this over to Hunt and let him do the introduction of Tom.
Okay, great, thanks. We really appreciate Tom coming on. I think it's going to be a terrific introduction to something that's probably something we're thinking about all the time, cognitive things. But let me introduce Tom first. He was raised in Western New York State, majored in psychology at Dartmouth, and got his MD at Cornell. His neurological residency and medical genetics fellowships were at the University of Washington in Seattle, where he has spent his entire career, except for 2 years in the Navy with the Marine Corps during the Vietnam era. He has been the Arthur Krauss Endowed Professor of Neurogenetics at the UW, University of Washington, Chief of the Neurological Services at the Seattle VA Medical Center. Sorry for all the words there. His special area of interest is genetic diseases of the brain and nervous system, including Alzheimer's disease, Huntington's disease, Parkinson's disease, and ALS. He has been a member of the research team that has identified the genes for 9 different diseases of the nervous system. In 1974, he founded the first clinic for adults with neurogenic diseases in the US. He directed the clinic for more than 40 years. He has received several national awards from the American Academy of Neurology, the American Neurological Association, the MetLife Foundation, and the Department of Veterans Affairs. He has recently published a book for the general public on his 50-year experience evaluating families with Huntington's disease. Tom, it's a pleasure to have you on, and a pleasure to take advantage of all your great expertise in this particular area. Now, Tom, we do have a poll. I think we ought to try it, which is to ask a couple of questions of everybody in the audience. And it's an anonymous poll. Whether this will work, I don't know. But anyways, we've got some questions, and I guess you may advise me on this. But the first question is, and this is to the audience, do you have a relative with Alzheimer's disease? So you can choose yes, or you can choose no. And so far, the polling says, well, here, let's finish. Maybe you can see how you can vote there, okay?
You got to do all the questions, I think.
Okay.
Hey, Hunt, I assume that means a blood relative, right?
Yes.
Not- Okay.
Yeah, blood relative.
Okay.
Okay, well, we'll go down the list here and then you can vote it and then we'll come back to it. Do you have a relative with dementia? Third question, are you concerned about getting dementia? Like, I think I know how that one's going to go. Do you think your memory is worse than others in your age group? That's so let's just take a breather and we'll see how it goes. Again, as I say, it's all anonymous, but I think whatever, it gives us a sort of a reference point here for what people are thinking in the audience. So Gus, shall we go ahead and
Share results.
share results? So for the number one question, do you have a relative with Alzheimer's disease? 72% said no. And so the vast majority were no, but 28% said yes, which is a pretty high number, Tom, don't you think? It's
actually just about what you would expect.
Is that right? What you would expect? Yep. Okay.
Yep.
Do you have a relative with dementia? And 68% said no, 32% said yes. So maybe that's in keeping. The third is, are you concerned about getting dementia? And 68% said yes. So, you know, it's clearly on the minds of everybody in the audience, or most of the people in the audience. The fourth one is, do you think your memory is worse than others in your age group? And so the choice was no. 80% said no. What do you think, Tom? Sound about right?
Denial is part of the whole
Okay, I understand. That's great. Well, it's interesting. I don't know if that helps categorize our audience here, you know, with people who are our age, but it gives you a little flavor of what's going on in the minds of the people who are listening to you. So, Tom, why don't you go ahead and talk about your career, talk about your experiences at Dartmouth, and things you want to talk about with what you've discovered. Thank you, Tom, for coming.
Yeah, thanks so much for inviting me. It's a delight for me to do this. I'll be talking about things I love to talk about, so I can easily go on and on, but I'll try and limit some of the things I'm saying. I'd very much like to open it up to questions at the end, so I think we'll have plenty of time. I do have some pictures that I forwarded to Gus, and hopefully he'll be able to show those a little later. But Hunt and Gus asked me to just begin by beginning at Dartmouth. As he said, I majored in psychology. And one of the themes of my career has been mentorship. I've really been lucky in finding some mentors who have made a very big difference in my life and in my career. And at Dartmouth, it was a guy by the name of Francis King. And he was in the psychology undergraduate department, but he was also in the department of psychiatry at the medical school. He was a PhD in psychology, and he was Dartmouth's clinical psychologist for the undergraduates, and his office was at Dick's house. And I met with him on a very regular basis in his office at Dick's house, and we talked a lot about issues about psychology and behavior. And then I spent the summer after we graduated working with him at Dick's house. And he went on to actually marry the head nurse at Dick's house. And so I spent a lot of time at Dick's house, and I learned a lot about psychology. I got very interested in academics. I got very interested in behavior psychology. And I actually learned a lot about how you run an undergraduate health service. So Dick's house was fantastic. And at our 50th reunion, I went back to Dick's house and walked through there, and it hasn't changed a bit. The lobby looked exactly the same. I think maybe the chairs are the same. And I saw the office where I used to hang out with him all the time. I then went on to medical school, went to Cornell Medical School in New York City. My colleague in crime there was Bob Reedy. We were basically roommates. We had a great time, learned a lot about medicine in New York City. And I ran into another mentor, and this time it was a guy named Fred Plum, who was the new chairman of the Department of Neurology at Cornell. And he took me under his wing, and I started to do research in diseases of the brain. And I went to all the weekly neurology, neurosurgery grand rounds conferences there, where they presented case after case after case of people with interesting neurologic diseases. And it just fascinated me. I fell in love with it. And so I then went on to internship and residency in neurology at the University of Washington. One of the reasons I went to the University of Washington was because my wife, Roz, is a native of Tacoma, and she got me to travel out there. And until that point in my life, I'd never been further west than Buffalo, New York. And so to see the Pacific Northwest was just amazing. I was blown away by it. And we moved to Seattle and haven't left in more than 50 years, except for those 2 years I spent in the Navy with the Marine Corps in San Diego was right in the middle of my residency because the Vietnam War was still in progress. And so every doctor graduating from medical school had to go into public service in some way, either the Army, the Navy, the Air Force, or the Public Health Service. But when I returned to the University of Washington and finished my residency, I ran into yet a third mentor, a guy by the name of Arno Maltulski, and he was an internist and a hematologist, and he had a fascination with genetics, and he decided to form a division at the University of Washington that would introduce genetics into all the specialties of medicine. And now that's done automatically. All the specialties of medicine are heavily into genetics these days. But back in the 1950s, he and a guy at Johns Hopkins were the first to start divisions of medical genetics. And I, as a senior resident, I went to his clinic and began to see patients with genetic diseases of the brain and the nervous system. And I just thought it was amazing. I just had a wonderful time, fascinating diseases. And so I got a fellowship with Maltulski in medical genetics at the UW. And that really set my career going in that path, which was studying genetic diseases of the brain and the nervous system. And I haven't stopped since. The first disease I started to study was actually genetics of multiple sclerosis. I didn't get very far. I quickly switched to a different disease called Charcot-Marie-Tooth disease, which is pretty rare, but it's a disease of the peripheral nerves, and it causes weakness and atrophy of the hands and feet, and it's inherited. It often begins in adolescence. It doesn't limit lifespan, but people frequently end up having to use braces on their feet. But it's called an autosomal dominant genetic disease. So if you've got it, each of your kids are at 50% risk. So we found a lot of families with this genetic neurologic nerve disease. And at that time, the idea was, can you place the theoretical genes for these disease on specific human chromosomes? And you did it by collecting blood samples from everybody in the family and looking at their blood groups and matching up the blood groups with whether they had the disease or not. And it was very difficult to do because there were very few blood group markers that you could use. But in our case, it was a success. We were able to place this kind of Charcot-Marie-Tooth disease on a human chromosome. And that was only the second time that had been done for a neurologic disease. And so it was really fascinating. And no one thought they were going to find a gene. No one had found a gene for any disease at that time. So that brings us up to about 1980. At that same time, I was the chief of neurology at the VA hospital. So I had these two clinics, one at the VA and one at the university, where I was seeing people with these diseases. And in 1980, what had happened in the world of neurology was that people were beginning to say, yikes, Alzheimer's disease is really common and really important. And when Bob Reedy and I went to medical school, we were taught that Alzheimer's disease was a rare disease. People got it in their 50s and 60s. It was very uncommon. You weren't likely to see anybody with it, and you didn't think much about it. And then in the early 70s, it was discovered that that's not true, that in fact, the most common cause of dementia in the elderly is Alzheimer's disease. It used to be thought that that elderly dementia was senility. You got it because of aging or because of hardening of the arteries in the brain. And it turned out that neither of those things were true. If you looked at the brains of people with late onset senile dementia, in fact, what you saw under the microscope was Alzheimer's disease. And so the National Institutes of Health said, oh my God, if this is true, then Alzheimer's is not a rare disease, it's a common disease because senile dementia is common. And not only that, it's going to become more common because of the aging of our population. The elderly age group is ballooning because everybody's living longer. So we're going to end up with millions of people with this Alzheimer's disease in our country, and we don't have any idea what causes it, and we don't have any idea how to treat it. So they scrambled around and they said, well, so the approach would be to establish academic research centers specifically studying Alzheimer's disease around the country. And they started to fund those in about 1983, 84. And my group at the UW came to me and said, Tom, have you seen any families that could have a genetic form of Alzheimer's disease? And it just so happened that I had several families who had come to me over the years, and they had a genetic Alzheimer's disease. They had multiple people in the family with the disease, and it looked genetic. So we said, okay, let's see if we can do what you did with Charcot-Marie-Tooth. Let's gather these families up, get blood samples from them, and see if we can place their disease on a human chromosome. And then at that time, so now we're into the 1980s, people were beginning to say, we may be able to actually find the genes. The technology had changed so that there was some hope that you could actually identify genes for diseases now, although in 1983, that had not been done yet. So we said, okay, we're going to look for a gene for Alzheimer's disease. We applied for an NIH center and we were turned down. The reason we were turned down was because the reviewers said, this is crazy. Alzheimer's disease is not a genetic disease. So you're chasing something that doesn't exist. But we came right back the next year, and I subsequently had found more families with what looked like familial Alzheimer's disease. We'd gotten a lot of brain autopsies in the families, and it clearly was Alzheimer's disease. So we were able to make a really strong case that there was some form of Alzheimer's disease that was genetic, and we got funded. And to make a long story short, we eventually did exactly what we said we were going to do. In the first few families we were able to place the probable gene for the disease on a human chromosome, and we did that. And then another group found that gene. And then I had a really fortunate coincidence that came along, and that is I was contacted by a family that were ranchers and farmers in the panhandle of Oklahoma. And they said, Dr. Bird, you've got to come and study our family. We've got familial Alzheimer's disease. So I made a road trip to the panhandle of Oklahoma, saw this family, and they were absolutely right. I was blown away by this family. There was part of the family was a sibship of 14 brothers and sisters. And over the years, eventually 11 of them developed and died of Alzheimer's disease. And they had other family members over several generations with the same disease. And so they were an amazing family to start studying. We started drawing blood samples from them. And it turned out that they were not your run-of-the-mill ordinary family because of their ethnic background. And they told me, we're Volga Germans. I'd never heard of such a thing. I had no idea what they were talking about. And they belonged to a national society. And the national society was called the American Historical Society of Germans from Russia. And its headquarters was in Lincoln, Nebraska. I'd never heard of it. But it turns out to be true. These were a bunch of people who were Germans that had migrated to Russia during Catherine the Great's reign, and then migrated to Nebraska and Kansas and Colorado at the turn of the last century. And by happenstance, some of them had genetic form of Alzheimer's disease. And in addition to this one big family in Oklahoma, we were eventually able to find 10 other families with the same genetic background who also had Alzheimer's disease. And we were able to say, hey, although the families didn't know each other, they probably all had the same gene for the disease because they had the same ethnic background. It turned out they were from the same two villages in Russia and their ancestors. So we were able to lump together their data, and we had hundreds of data points instead of just a few dozen. And sure enough, that's what happened. My molecular biology colleagues were able to pinpoint the chromosome, the disease in these families were on, and then able to identify the actual gene causing Alzheimer's disease in this group of families. And by causing, I mean that if you had the mutation in the gene, you would develop the disease if you lived long enough. And that usually was in your 40s, 50s, or 60s. And each of your children had a 50% chance of inheriting the same thing, developing it, and passing it on. So it's called an autosomal dominant disease. It's rare, but it causes Alzheimer's disease. We also, by the way, realized that some of the families we thought had Alzheimer's disease did not have Alzheimer's disease. They actually had another disease that's now known as frontotemporal dementia. It's actually a relative of CBD. Somebody mentioned that they knew about CBD. So this frontotemporal dementia is a neurologic relative of CBD. We found families with a genetic form of that, and my molecular colleagues in our group were able to find a gene causing frontotemporal dementia. And as Hunt mentioned, we went on to find the genetics and the genes causing 9 different diseases of the nervous system. So, and that's what I've spent, the last decades doing. It's been just a fantastic trip. And I've had marvelous colleagues at the University of Washington helping me work on these projects. And Hunt, are you able to show the slides?
I can show them, Tom.
Yeah, let's take a look at them.
Tom, quick question.
Yes.
Somebody asked, what's the difference between Alzheimer's and dementia? Are those?
Yeah, so I'll actually get to that, but the answer is dementia is the overriding diagnosis. It means you're having cognitive decline, and there are 100 different causes of dementia. Alzheimer's is a specific form of dementia that has the characteristics I'm just about to show you.
Right.
It's like there are a lot of kinds of anemia. Dementia is like anemia, and you can have iron deficiency anemia, you can have pernicious anemia, and so forth. You can have a lot of different kinds of dementia. So is this showing? Can people see this?
Yes.
Yep.
Tom, do you want me to show this as a slideshow, or is it okay the way I'm doing it right now?
Why don't you show it as a slideshow? If you can.
I don't think they can see you while you're talking.
If you can't, this is all right.
Anyone has questions, please put them in the chat.
So we can go with this, Gus. This is just to start us off. This is my hometown. It's what it looks like on a nice day. Today was a pretty nice day. So let's go to the next one, Gus. Can you advance the slide?
So, Tom, I think I'm going to have to do it a slightly different way.
Yeah.
So can everybody see Seattle? Can everyone see?
There we go. You got it.
Alzheimer?
You
All
got
right.
it.
Okay, I can't do it as a slideshow. I'm gonna have to do it in this mode, which is a little bit clunky.
Okay.
So go ahead, tell me when to go to the next slide.
Yeah. So this is great. This is the guy that started it all. This is Herr Professor Dr. Alzheimer. And he described this disease 115 years ago in Germany. Let's see the next one, Gus. So this is his patient that he described in 1906, 1907. And her picture was left in his record and her record was rediscovered in the 1970s. And here's the amazing thing. So this disease, Alzheimer's disease, that millions of people have, that billions of dollars is being spent on, it was initially described in a single patient, this one woman. Alzheimer was a neurologist and a psychiatrist in Frankfurt and Würzburg, and then Munich and Heidelberg. He traveled around and he reported her clinical findings, which were severe progressive dementia. And she was 50 years old. And that's one of the reasons that initially everybody thought Alzheimer's disease was a rare disease of people in their 50s and 60s, because she happened to be 50 years old. And then she died. And he was also a neuropathologist. Let's see the next slide, Gus.
Excuse me.
So this is a normal human brain. And in the center are the ventricles that contain the cerebral spinal fluid. And the little curly things off to the side on each side are called the hippocampus. And that's really where memory tends to be focused. Yeah, perfect. That's the hippocampus. So let's see the next slide. Here's a brain with Alzheimer's disease. This is what Alzheimer saw in his patient after she died. And you don't have to be a pathologist to recognize there's something wrong with this brain. It's atrophic. And so the spaces have gotten bigger and the substance of the brain has shrunk. So those ventricles have gotten huge. They're way bigger than they ought to be. And if you try to find the hippocampi over on the sides, you can't hardly find them. They've almost disappeared because of the size of the ventricles and the atrophy of the brain. There are a lot of different things that can do this, so you need more than that. And let's see the next slide. And so Alzheimer looked at the brain tissue under his microscope, and this is what he saw. In the lower left-hand corner is called a senile plaque. And he didn't know what that was composed of, but now we know that it's primarily composed of a protein called amyloid. And you'll hear a lot about amyloid when you hear discussions of Alzheimer's disease. And then if you look in the upper right-hand corner, that's a neuron, a nerve cell, that's dense black because it's full of stuff called neurofibrillary tangle. It shouldn't look like that. And it contains a protein called tau. And those two proteins, amyloid and tau, when they accumulate in the brain, are toxic. They kill neurons and they lead to dementia. And so the trick that people have been working on for the last 20 years is how can you prevent the accumulation of amyloid and or tau in the brain, and that ought to prevent the disease. It hasn't happened very successfully yet, but that's what people are working on. Let's see the next slide. So this is just an example of one of those families that I saw in clinic. This is you can see it's a 4-generation family, and the men are squares and women are circles, and everybody in white has died with or has Alzheimer's disease. So 22 people in this family have developed Alzheimer's disease. And this is why we were able to tell the NIH reviewers, in this family, this is a genetic disease. And they'd all had autopsies. The capital A next to people means they had an autopsy, and they all showed the amyloid plaques and the neurofibrillary tangles. So we knew it was Alzheimer's disease. And you can see down at the bottom of the slide, it says the mean age of onset in this family was 41. So that's one of the characteristics of these genetic forms of Alzheimer's disease, is that they come on early. This is what, of course, Alzheimer had described, but it's not typical of run-of-the-mill Alzheimer's disease in the general population. Let's see the next slide. So this is a picture of that family that I went to see in the panhandle of Oklahoma. This is the SIB ship of 14 people. They gathered for one of their high school reunions and took this picture. 14 people, and eventually 11 of them died with Alzheimer's disease. When I came across the family, something like 8 or 9 of them had already developed the disease, and they went on, as I was studying them, 2 or 3 more people developed it. So it just devastated this family. And their father had died of the disease, and he had some siblings that had died of the disease, and their children had the disease. So this group had cousins with the disease. So it was a huge family, and it led to this discovery of one gene causing Alzheimer's. Let's see the next slide. So this is the genetic story that we now know so far for Alzheimer's disease. And every one of these circles on this graph is a gene that has been associated as a risk factor for Alzheimer's disease. You can see there are 20 or 25 of them. But the thing to notice is that on the x-axis, it goes from extremely rare to very common. And on the y-axis, it goes from a very low risk to a very high risk. And those 3 red circles up in the upper left-hand corner, those are the 3 genes that have been found that cause the genetic form of Alzheimer's disease. And the one that we found in the Germans from Russia family is called presenilin 2. It's called PSEN2 up in the corner. So you can see right next to it, it says causes Alzheimer's disease, a genetic cause. But down at the bottom, you can see it falls into the range where it's really rare. And it turns out that these 3 genetic causes of Alzheimer's disease represent about 1% of all Alzheimer's. So they're very rare. You're not likely to come across a family like this. The group in the lower right-hand corner of the graph, there are a whole bunch of genes there. They are risk factors for Alzheimer's disease. And although they're common, you can see they're down at the bottom, they're low risk. So each one by itself represents maybe 0.5 to 1% risk for developing the disease. But this is why there are some people in the general population, if they have the right forms of, say, 5 or 6 of those genes, they're much more likely to develop the disease. But the odds that you will have 5 or 6 of those is fairly low. The one that's a bit strange is the one in the middle of the graph called ApoE. That's both common and has a modest amount of risk. And the genotype is called the number 4 genotype of ApoE. You get one from your mother, one from your father. If you have one ApoE genotype, you have a medium risk for developing Alzheimer's disease. And then over on the left, you can see if you have 2, if you got the 4 genotype from both your mother and your father, your risk is fairly substantial for developing Alzheimer's disease. It is not as high as the genetic causes up in the upper left, but it's getting up there. It's a substantial risk factor. Let's see the next slide. And this is what we're all facing. This is why some of you answered the poll questions yes. This is our age cohorts at the bottom going from 65 to 100. And then the frequency of having a dementia or Alzheimer's disease in that age group. And you can see that in the early 70s, the frequency is pretty low, like maybe 3, 4, 5%. But if you get up to 80, which we're beginning to face, you're up around 10, 12%. And as you move through your 80s, through the next coming decade, the frequency of Alzheimer's disease and dementia goes up to 25, 30%. And in the 90s, it goes higher, although some studies have shown it leveling off and others, it doesn't level off. It's not so clear. Not that many people have been studied. But that means, you know, for us in our age group, if you're in a group of 10 people, as they move through their 80s, you can predict that at least 2 or 3 of those people are going to develop dementia. So that's the kind of risk that we're facing. And let's see the next slide. This is the best prevention for Alzheimer's. Red wine and chocolate. That's a little bit tongue in cheek, but the point is there is no really good treatment for this disease. There's no really good preventative. People talk about exercise and exercising your body, smoke, don't drink heavily, treat diabetes, treat high blood pressure. Those are all good things to do, but they don't have a huge impact on those plaques and tangles in the brain. So I think I'll stop there, Gus, and leave time for questions.
You have your book on the next slide. Didn't show it.
Tom, what when you talk about you know, the plaques, that's and not smoking and not drinking and all that. What's the generative process here? I mean,
Right. So
why is it always those things that you know, we want to do?
right.
Why are they bad for us?
So this actually goes back to the first question we had. What's the difference between dementia and Alzheimer's? And there's a lot of waving of hands that goes on. And the larger category of dementia, vascular disease in the brain actually can produce dementia. I didn't talk much about that, but severe untreated hypertension, severe untreated diabetes, severe untreated atherosclerosis can actually cause blood vessel deterioration in the brain that can cause brain damage, and that can cause dementia. So when people talk about preventing dementia, they quickly talk about treating blood pressure, treating diabetes, not smoking, not being alcoholic, and that definitely reduces your risk for dementia. But they're actually not talking about Alzheimer's disease. Alzheimer's disease is those plaques and tangles, and those things I just mentioned, as far as we know, don't really have an impact on the plaques and tangles. So you can help prevent your risk of developing dementia, but not so much true Alzheimer's disease. But it turns out a lot of dementia in the general population is a combination of those things. You find Alzheimer's, but you also find microvascular disease and find other things as well. The same is true, for example, of Parkinson's disease. People with Parkinson's disease have a very high risk for developing a dementia, and they get a different protein accumulated in their brain called alpha-synuclein, but it can combine with these plaques and tangles and cause dementia.
Tom, this is Bob Reedy.
Yeah, hi, Bob.
I have a couple of questions, and you really touch on that. That is, can one accurately make the diagnosis of Alzheimer's disease in the absence of a brain biopsy?
That's a great question. And 20 years ago, I would have said no. The gold standard for the diagnosis of the disease is looking at the brain under the microscope and seeing the plaques and tangles. That's changed in the last 20 years. And there are two things that have changed, Bob. One is PET scanning. There are now PET scans where they have ligands that they inject into your blood, into your vein. The radioactive ligands go to the brain and they actually link to amyloid and they light up amyloid. And so you can do a brain amyloid PET scan and you can quantitate how much amyloid is depositing in the brain. You couldn't do that 20 years ago, but now you can. And you can do a spinal tap, and in the spinal fluid, you can measure amyloid concentration and tau concentration. And if you take those things, the amyloid PET scan and spinal fluid tau and spinal fluid amyloid, if all the pieces fall together, then your chances of being accurate about the diagnosis of Alzheimer's is very high. Most neurologists don't go to the lengths of doing that but it's now possible.
And then I have another question. You noted that those amyloid plaques and the tangles are characteristic of people that have Alzheimer's disease. But is there any proof that they cause the disease, or are they just a manifestation of the disease being caused by something else?
Right.
And the reason I ask that question is there's a lot of money and a lot of hoopla about chemicals and medicines that will reduce amyloid in the brain. But does that make any difference? Is that just a byproduct of the disease itself? And that, whether or not you get rid of the amyloid doesn't really impact the course of the disease for that patient?
That's a great question, and it's the $64 question or the $64 billion question, and these amyloid treatments all got started with mouse models. So you can create mice that overproduce amyloid, and they become cognitively impaired. They can't run their maze very well anymore. And if you remove the amyloid that they've accumulated, they get better. So everybody said, "Oh, great, that's how you cure Alzheimer's disease." And so, as you probably know, Bob, over the last 20 years, there have been more than a dozen treatment trials of treating amyloid for people with Alzheimer's, and they're using the same kind of thing where you basically inject various kinds of antibodies that go to the brain, latch onto the amyloid, and pull it out of the brain. And they've shown that they can do that. They can pull amyloid out of the brain. But all those treatment trials have failed. They didn't improve people. They failed. The only one that the FDA has approved, was just approved this year. And even that was controversial. And I actually fell into the side of the advisory committee for the FDA, who said they should not approve it. And the reason is they were approving it on the basis of exactly what you just said, the documentation that it was removing amyloid, and it was by spinal fluid and by the PET scans, they could show it was removing amyloid. But the evidence that it was actually improving the patients was not good. But the FDA and the advisory committee said for that reason, it shouldn't be approved. But the FDA countervened their advisory committee and they approved it. So it's out there now. It costs $56,000 a year. It's injected intravenously, and we'll see what happens. But
Thank you.
It's partly because I happen to be a guy that really believes in the importance of tau. And there's a lot of evidence that those tau particles in the neurofibrillary tangles that are probably causing the disease. Somehow amyloid sets that off. And it's the neurofibrillary tangles that are probably causing the dementia. And nobody has a treatment for that tangle formation.
Tom, it's Hop Potter. Remember our trip to Vietnam?
I absolutely do, yes.
Hi, Phil. Hi, Alan. Yeah, okay, I digress. I was wondering if you could talk a little bit more about the relationship between Alzheimer's and death or early death. We had a case in my family pretty close to home, which for convenience sake, we have blamed on Alzheimer's. We don't know that that's true, but that was convenient to say.
Yep.
It's my mother I'm talking about. She died at our age, exactly the age of this learned group that we're all joined in here today.
Right.
Can you talk a little bit about Alzheimer's and death or early death?
Yeah, so Alzheimer's is a progressive degenerative disease. And when someone has it, they're going to die from it. And the time course varies quite a bit from patient to patient, but the typical time course is about 8 to 10 years. And first they lose their memory, then they lose other cognitive abilities, they lose trouble talking, They have trouble swallowing, they have trouble walking, they often end up in a wheelchair and then a bed, and die frequently because they can't eat, they become malnourished, they get infections, they have aspiration pneumonia. That whole process typically takes about 8 to 10 years. There's some people that go much faster than that. I've seen people that have died within 3, 4, 5 years. And I've seen other people that have gone 20 years. And so the brain disease itself doesn't cause death, but all the things that happen to you because your brain is disappearing results in death. And that is your inability to eat. And so you become malnourished, your inability to swallow. And so you get aspiration pneumonia, you get bed sores. And so, you get the physical dwindles as well as the dementia. And that's what people die of. But there's no question that people will die earlier if they have that disease. And those families that I showed you who develop the disease in their 40s and 50s, you can imagine what a disaster that is for them because they're dying in their 50s and 60s.
Yeah. Thank you. It's complicated.
Yeah, yeah.
So Tom, we're approaching the 80s, our 80s. And what was the percentage of those in the 80s who would develop Alzheimer's or
It was about 25%.
25%?
Yep.
So 1 out of 4.
Right.
And there's not a lot we can do about that.
There isn't.
Yeah.
Red wine and chocolates.
Tom,
Yes.
Ray Peters,
Hi, Ray.
I've been diagnosed with CBD.
Yes.
And a lot of the discussion that you just engaged in sounds very familiar, including the buildup of tau in the brain, which they think may be really, but the CBD is a very rare disease. I have 1 in 100,000. Does it bear any relationship that you know of to Alzheimer's?
Yes, it does. So I briefly mentioned when I got into some of the other diseases that we had studied, another disease called frontotemporal dementia. It's also known as FTD. And the families that we found with that FTD disease, the gene that has the mutation causing that is tau. So these families accumulate tau in their brain. They don't have amyloid plaques, but they have neurofibrillary tangles and tau accumulation. And they get this progressive dementing illness called FTD. And it's quite similar to CBD. CBD is cortical basal degeneration. And it's also a tau disease. And so everybody talks about it as overlapping with frontotemporal dementia. So it's very rare, as you mentioned, but it's in that ballpark of what are called tauopathies, diseases that have a tau pathology, and Alzheimer's is one of those diseases because of the neurofibrillary tangles. So Alzheimer's is basically a tauopathy and also an amyloidopathy, whereas CBD and frontotemporal dementia are just pure tauopathies.
And there seems to be a fair amount of interest in running trials to see whether or not tau can be reduced or the effects.
Yeah, there's a huge interest in that. That field is far behind the amyloid field. The amyloid field for reducing amyloid has been going on, as I said, for more than 20 years. Being able to reduce tau is pretty new, and it's harder to do. But there's a lot of interest in it because it seems to be critical. It's critical in Alzheimer's disease, I think.
Yeah.
You can remove the amyloid, but if you can't do something about the tau, you're still in big trouble.
Right.
So there needs to be a therapeutic a target of treating tau.
Hey, Tom, this is Ed Jingers. I fascinated you. I really appreciate your presentation, but I see a lot of these ads on TV where a lady said, I'm sort of fuzzy on memory, but I take Prevagen these over-the-counter things. I mean, it's obviously not chocolate or wine, so it's probably not doing anything. Is there any merit to, I mean, they seem to spend a lot of money on advertising, and friends of mine take it,
Yeah,
but I don't know if it has any merit at all to its,
I think it's placebo.
it's a placebo. Yeah, that's my
Yep.
feeling.
Yeah.
It's such a
But
vague
people-
advertisement.
People want to take something because, in our age group, you think we all have some trouble with our memory. I have particular trouble thinking of people's names. I'll see somebody on the street. I can tell you everything about them, and I can't think of their name. and it drives me crazy. So everybody knows that they are having memory trouble, and they want to do something about it, and they're really worried that it's going to get a whole lot worse. And so they try a lot of things, and hopefully they try things that don't harm them.
Well, I'm getting ready to leave Seattle after 6 months and going back down to Palm Springs. And every year I get the membership book and I study it so that when I see my friends who I haven't seen, but that 6 months seems to be enough time to forget exactly. I do remember playing golf and use something specific, but not the actual name or
Right.
wife's name.
Right. Yeah.
So I'm not going to take any Prevagen then.
Right.
I had a conversation with my pharmacist who had a big display of Prevagen out on the counter, and I said to him, "Does that stuff really work?" And he shook his head no. And I said, "Well, why do you have a big display on it?" And he says, "Because our customers want it, and we're a local neighborhood pharmacy, and we're trying to make our customers help our customers be satisfied.
Yeah.
So if they think it works, it works." And that's why we stack it up there. And so he's saying, placebos work and they're also good for business.
There are people that are going to China and Switzerland and Mexico and Chile for stem cell treatments and for all kinds of things, spend thousands and thousands of dollars, and it doesn't work.
Tom, I've got a question about, I submitted one, but is there any evidence that an imbalance in trace elements could affect the formation of these taus and amyloids? I'm thinking specifically of cobalt, which is a transition metal that I believe is needed to activate certain vitamins. I was wondering if it has the same sort of neurological effect in the human brain.
They're all useful ideas to work on. It's really hard to sort out what's going on at the chemical level. You may recall quite a few years ago, there was a huge enthusiasm about aluminum, that aluminum had something to do with Alzheimer's, and people were throwing away their aluminum cans, and they were worried about deodorants that had aluminum in it, and on and on. And it's because in rabbits, if you inject aluminum into rabbits' brains, they get neurofibrillary tangles. So that's interesting, but it turned out to just not be the case. It just wasn't not involved in Alzheimer's disease. And the same thing has gone on with mercury. A lot of dentists take out people's teeth because they think it's going to prevent Alzheimer's, but it's just not the case. So, copper, zinc, cobalt, they're all important in the brain, and you can have deficiencies of those metals and they can cause problems. But to tie it into Alzheimer's has not worked so far.
Tom, Sandy McGinnis, hi. And
Yeah,
thank
hi.
you for an excellent presentation. Can you describe the effort going on now, both by the federal government and private companies, to try to solve the Alzheimer's problem?
Right. There's a huge amount going on. And it's on the one hand, it's very popular with private pharmaceutical companies because, there are millions of people with the disease. So, they've got dollar signs in their eyes because it's a potentially billion dollar treatment. On the other hand, they've been trying for 20 years now with attacking amyloid, and it hasn't worked very well. And that's disappointed a lot of them. But they haven't stopped because it affects so many people. And the federal government is extremely important because of the number of people. Millions of people with it. You got to try and do something about this disease. And so NIH is putting billions of dollars into Alzheimer's research. And it's focused on the amyloid and the tau, but they realize you got to look at some other things as well. And so they are. So there's a lot going on. And if you look back on it, it's been extremely successful. What we know about this disease now compared when we got started in it more than 40 years ago, it's just been huge. Nobody knew what amyloid was. Nobody knew what tau was. Nobody knew what the genes were. That was all unknown. And that's all been discovered and worked out in the last few decades. So the advances have really been impressive, but it just hasn't yet led to a treatment. I think part of the problem, Sandy, is that what we're beginning to realize is that Alzheimer's probably isn't a single disease. And there are probably multiple kinds of what we're calling Alzheimer's. And there's the genetic kind that I was talking about. And we know there are 3 genetic kinds. And then there's the kind that is Alzheimer's with vascular disease. And there's the kind that's Alzheimer's with Parkinson's disease. And there's the kind with frontotemporal dementia. So there are probably a lot of different kinds of Alzheimer's. And if you just throw several hundred people into a treatment pot, your treatment may actually be helping 10% of the people, but you don't know it because you're studying such a large number of people. So that makes it tricky too. And I think the fact that we're probably trying to treat several different diseases makes it difficult.
Tom, Harvard Teitelbaum asked, is there any evidence that the voice tests can diagnose Parkinson's?
There's some evidence. There are a couple of things that people have touted for Parkinson's. And one is the people with Parkinson's disease have a voice problem. If you have a friend or a relative with Parkinson's, you'll notice that their voice often gets soft and raspy. There's no question that the voice changes with Parkinson's. So some people have said, well, you can do careful voice tests and pick it up really early. How good they are, I'm not so sure. Another one is a smell test. People with Parkinson's lose their sense of smell, and they do. And some people have proposed that doing smell odor tests on people will pick it up early. Maybe yes, maybe no. There's another condition called REM sleep behavior, where people in sleep go wild at night. They have wild dreams and they kick and they thrash around, and sometimes they fall out of bed and sometimes they hit their spouse. And it's a known condition. It's called REM sleep behavior. And that clearly is a precursor of Parkinson's disease. They've now followed people with that REM sleep behavior, and something like 80% of them go on to develop Parkinson's disease like decades later. So there are things that happen early that you can pick up on, but there aren't great tests for it.
Tom, what optimism do you have that in the next 5 years, there's going to be some major advancement, that provides some help?
So my 5-year optimism is fairly low. My 10-year optimism is quite good.
Okay.
So it's slow business. It doesn't happen overnight, but there's no question that progress is being made, and I think things are going to look a lot better in the next decade. And in the next couple of years, I'd be surprised if there's, people always talk about breakthroughs. I think that's a very overused term.
So Tom, as our class doctor, do you recommend then that we try to live at least 10 more years?
Good point.
I think we should go for 20.
Okay, very good.
I have a colleague of mine who is a social worker, and she just died this year, just a couple of months shy of 106.
Oh, my word.
And she was sharp as a tack. Wonderful person, very active. She did Tai Chi all through her 90s. A really neat person. Her mind stayed very good, and she lived to be 105.
Well, it's encouraging because it means that this dementia of whatever variety is not inevitable for all of us.
I think so. People think there's still a debate that goes on is, would we all become demented if we lived long enough? I work very closely with a lot of neuropathologists, and in our Alzheimer's Center, we're in the business of collecting brains of people after they die. And we've seen a bunch of brains in people over the age of 95. And yes, most of them have what looks like Alzheimer's disease, but we've seen several that have no pathology and they were not demented.
Yeah.
So it happens.
Tom, what's your secret? What's your secret?
I don't have, red wine and chocolate is what I stick with.
Tom, this is Bert Alamansky. A great deal of the conversation today has surrounded Alzheimer's. About 2 years ago, after an accident, I was diagnosed with Parkinson's. And so I've been poking around to learn as much as I possibly can about that. Is there activity, positive activity, strides being made in being able to, appreciate how to approach Parkinson's?
Yes, no, Parkinson's is a big deal because there are millions of people with Parkinson's disease. It's not quite as common as dementia, but Parkinson's is a very common disease. There was literally a breakthrough in Parkinson's disease back when Bob and I were residents, and that was L-DOPA. The L-DOPA treatment of Parkinson's was just amazing. You gave people a pill, and they went from wheelchairs to playing golf. It was quite dramatic. So that was a very big deal. But that's now been around for 40 years, and it doesn't cure the disease. The disease still progresses. So people have tried to find something that's even better than L-DOPA. And deep brain stimulation has also been quite remarkable. It's used a lot, and it does help people. But again, it doesn't cure the disease. And so people are working very hard, and it's now known the protein that's accumulated in the brain in Parkinson's, just like it's amyloid and tau and Alzheimer's, it's a protein called alpha-synuclein in Parkinson's. So people are working very hard on how can you prevent the accumulation and toxicity of alpha-synuclein. And I think that there's a lot of good work being done.
One of the things just one footnote on all that, one of the things that I found absolutely amazing is the number of people who get together in support groups for other people and colleagues who are involved, have Parkinson's, and have and sharing information about it and socializing about it, raising money. It's very, very impressive.
Yes, and the same thing's happening for Alzheimer's as well. And Gus, I don't know, Gus, can you show my last slide? Speaking of, I'm glad you brought that up. Speaking of support groups, I actually have a last slide. And if you want to learn more about what I've been doing the last 50 years, I wrote this book, and it's actually about another genetic brain disease that I've spent a lot of time studying called Huntington's disease. It's the disease that Woody Guthrie had and died of. And I've seen more than 1,000 people with Huntington's disease. It's an amazing disease. And I became so fascinated by that when I retired, I wrote this book about what it was like taking care of these people and evaluating these people. And I have a chapter in there about how similar it is to Alzheimer's and frontotemporal dementia. And there's a lot about genetics in here, but it's for the general public. So if you ever want to know more about the kinds of stuff that I've been doing, take a look at this. That's my commercial.
Good.
Great commercial. Thank you. Thank you very much for this presentation tonight. Much appreciated.
Take one more question here in the chat, and then I think we will wrap it up for the evening. The question is, Tom, are there any findings from the NUN-S study that are now being taken seriously?
Absolutely. So the NUN study is a study out of Chicago, and they accumulated several hundred nuns and got them to agree to be studied longitudinally in terms of their cognitive abilities. And then they all agreed to donate their brains when they died. And of course, their incidence of smoking and alcoholism was pretty low. And so they thought this was an interesting group of people to study. And that's now been going on for more than 25 years, I think, by a guy named Bennett in Chicago. And a lot has been learned about dementia and Alzheimer's disease from studying these hundreds of women and having really detailed cognitive information on them, and then taking a look at their brains under the microscope and correlating what they were like as living individuals, and then what happened to their brains afterwards. So that's known as the Nun study, and it's become larger. It's now called the ROS, the Religious Orders Study, and it's still an ongoing study, and it's been very valuable.
When are we've got still 46 people on the call, Tom. Anyone else have a question? Since I can sense that there's a real interest in what, yeah. Shaver? Yeah. Go ahead, Phil. Mute.
Unmute. You're muted.
Put your hand by your ear, cup your ear.
Ah,
Yeah, there you go.
hi, Tom.
Hi.
I was the one who sent in the question about the Nun study.
Yeah.
And actually what I was getting at, are there findings from the Nun study? Because I was familiar with it, that are still pertinent and that might be helpful now as we consider their findings. Because as I remember, when the autopsies, the brains were studied, the brains of these happy functioning nuns after they died were deteriorated, and yet they were happy and functioning and not showing the usual signs of Alzheimer's. So what was it about their lives that we can apply now and learn from?
Yeah, well, no one knows.
Oh,
No
I
one
thought
knows
they
the
came
answer.
to conclusions.
No, so a couple of things. So one is, your observation is really good. And that is that when you look at brains of people after they've died, there are individuals whose brains are full of plaques and tangles, and they meet the microscopic criteria for Alzheimer's disease, and they were not demented during life.
Right.
And we call them resilient. So for some reason, they're resilient. They get the pathology, but they don't get the clinical dementia. We also have another group of people who are also elderly. They're in their 80s and 90s. They're not demented. And when you look at their brains, they have no plaques and tangles. And we call them resistant. So we have groups of people that we call resistant, and we have groups of people that we call resilient. And we'd love to know why. Both of those groups, if you could figure out why, you'd have a good treatment for the disease, but it's still not clear why there are people who are resilient and there are people who are resistant. Another thing that got talked about in the Nun study was they went back and looked at when they became, at the very earliest they became nuns, usually in their teens. They looked at the stories that they were writing, the things that they wrote back when they were teens, and they analyzed those, and they came to the conclusion that the nuns that became demented were already having trouble writing when they were teens.
Oh.
And they were different from their cohorts who were writing much, it was sort of fluency, how many words were they using and how complicated were the things they were writing about, and their writings were much more simplistic, and they were the ones that went on to develop dementia 60 years later.
Fascinating.
And so, but no one knows what to make of that. There are a lot of studies that have claimed that that dementia is related to educational level, and the higher the educational level, the lower the frequency of dementia. That should make us all happy if you thought you got a good education at Dartmouth. but it's obviously not exact, and you know, and the tests that are used to decide whether people had, you know, adequate dementia education or not, it's not so hot. So I don't buy that correlation very much, but it's out there. It gets talked about a lot.
It's Bill Newcomb. May I ask a question about PCA? Can you talk a little bit about that?
Do you mean posterior cortical atrophy?
Yes, sir.
Yeah. So posterior cortical atrophy, that's a physical diagnostic term, meaning that the posterior part of the brain is undergoing atrophy. So frequently in Alzheimer's, the atrophy is diffuse. It's frontal, it's temporal, it's parietal, it's occipital. So it's a diffuse atrophy. There are other subgroups of neurologic disease where the atrophy is focal. And one of those I mentioned, that's frontotemporal dementia, and that's named because of the frontal and temporal lobes that atrophy, and the rest of the brain does. The rest of the brain doesn't. So there's a pretty rare subgroup that's called posterior cortical atrophy. That's the posterior part of the brain. That's the occipital lobe. That's where vision is formed. And those people often develop a kind of dementia that frequently is also involved with visual phenomenon of some kind. And when you do an MRI on them, you can see that the atrophy is much more posterior and occipital than other regions. And this is a nice example of what I was mentioning about how Alzheimer's is probably not a single disease. I think there's several different subtypes of it that we aren't able to pay enough attention to. And posterior cortical atrophy is one of those.
Thank you.
The cynics among us might note that those nuns that were so happy and they avoid dementia, they also avoided marriage.
I think we probably ought to, unless you got another question. Bill, did you have a follow-up on that? Bill, did you have a follow-up on that? Okay.
Thank you.
Is there another question out there?
One more.
Okay.
You've referred to the importance of studying the brain pathologically. Is there merit for individuals out of the blue to donate their brain to pathological study?
So there's a definite benefit to that. It's tied to what you know about them before they die.
Yeah.
So if somebody just dies and wants to donate their brain, you're not going to learn much from it if you don't know a lot about what happened to them. You want to be able to correlate what you see under the microscope with what they were like clinically. When did the disease begin? Was it language? Was it memory? Was it movement? Was it visual? And did they have an MRI? And did they have a PET scan? And did anybody look at their spinal fluid? And did somebody save a blood sample to look at DNA? So if you wanted to find out if it was genetic or not, you'd like to have a blood sample where you could look at their DNA. So if you've got all those things lined up and somebody has an interesting disease and they die, their brain is extremely valuable. It's not so valuable if it's just someone who, dies in a nursing home and you don't know much about them and they want to donate their brain. Not much is learned from that.
Appreciate it. Just a side comment. I'm likely to give money to hospice and palliative care at the local level than to buy Prevagen, based on what you've commented on this evening.
Yes. Hospice and palliative care are wonderful things, and we need more of that.
Yes.
There isn't a lot of that in a lot of communities, and it's a really valuable service for people with all kinds of medical conditions. I really strongly support hospice and palliative care. I just read this book by Atul Gawande on being mortal.
I've read it.
Yeah, and you can see the value of hospice and palliative care when you read that book.
Great. Listen, I think we ought to end it there. Tom, it's been wonderful to have you. You're a great speaker. You clearly remembered everything. A tribute to your professorship and clinical.
Let's see, what's your name? Tell me your name.
You're hunting for my name. But Tom, thank you very much for sharing your expertise, and thanks very much for your pioneering efforts.
Thank you. Yes,
You made a
fantastic
great
job,
gain
Tom.
in the
Thank
study
you.
of this. So we appreciate it.
It's been a pleasure, and I enjoyed
Yeah.
seeing a lot of familiar faces.
Yeah, good, Tom. Thanks very
Thank
much.
you, Tom.
again. Okay, good.
And for those who may want to watch this again or recommend it to others, we have recorded it, and it will be accessed in a couple of days on the Facebook page, I believe. Is that right, Gus?
Who's that? Who's?
Yes, we'll get it there. As long as Tom's in agreement.
Yeah, sounds
Okay.
good.
Thanks
Great.
all. Okay.
Thank you.
Great.
Thanks,
Well
Tom. Good night,
done,
all.
Roy. Well done, Roy.